So we are the crushing team. Our two crushings combined into one, and here's our new design.
So this is kind of a general overview of the full assembly. Obviously, the SolidWorks design does not have the two-sided flywheel implemented yet, and the sorting system is just kind of basic, but this is what it will generally hopefully look like when all put together. And then we'll move into talking about the actual crushing system.
So this is kind of our initial design of the crushing element. So not much has changed besides like the finalization of specifics. From now on, we're going to look at how we're going to integrate this subsystem with the rest of our subsystems.
So here's the assembly of our product. This is it broken down a little bit. The machine barrel is the key of this whole structure. It's the most expensive piece. It holds all the square stock, and then it uses the retaining plate to hold the square stock to the tube, or to the machine barrel. And that's about it.
Once all said and done, when you purchase everything from a MasterCard, it's coming about to $646. That's excluding the sheet metal purchasing for the hopper device. Everything that we're using in our prototype that we presented in each presentation has been hollowed out items. These would be completely solid items, which is why the price is elevated so much, because one of the requirements of our customer is to have this as durable as possible, being that it will be in weathering effects and be in use for all the time practically. So what we wanted to do is create a very, very durable system and allow for this to be crushing rocks practically all the time. So that's why this is such an expensive thing, is because it has to be able to withstand so much torque all the time and withstand a lot of fatigue.
The last thing is just kind of an overview of what we have left to do. We have already started a prototype, but there's some final things that we need to do to enhance it to make it like the actual final design. We'll test that again with the marble chips that we have found, making sure that in the prototype it works, and then, of course, scaling it. Our deadline for us is when we come back from Thanksgiving break or dead week. So that's what our plan is. It should give us enough time to test it out, make some tweaks if need be, and have a final product.
Are there any questions?
Jacqueline. So, with your bill of materials, obviously it is super expensive. Is there any way that there could be cutting costs, such as either trying to get from foreign building supply or using materials that might not be as great, but for like financial sake would be a little less?
Part of it is that we weren't trying to see how much it costs for like us to get the material, but how much it would cost them to get the material. So like using a discounted place that we have available wouldn't necessarily be what they have available. And as far as materials, like we are trying to make it really durable so they don't have to go back and fix things or it breaks, because then that kind of defeats the purpose of having it. So
We've cut the cost a lot, actually. So changing our tooth size from 1/2 inch to 3/4, we cut about $170. This is probably the most expensive part of the whole machine, so I don't see any other way to cut costs. It has to be able to withstand time. It destroys everything. So
I mean, if your crusher breaks, there is no system. So.
And just add my 2 cents, and then sorry, the questions were coming in a little low, but regarding the cost, in situations like this, you could think about if the people there applying for a grant or some sort of microfinance loan, right? So it may be a little bit of money up front, capital costs, but as you mentioned, if it's durable, that's a big thing. So yeah, maybe the cost is getting up there, but I think there's ways to handle that. And also, sorry, just a quick technical question. So I'm taking a look at a few slides back, I think, where it shows the schematic, and I like the schematics, so thank you. One more, I think. Yeah. So So you feed the rocks down, and then so the rock has to kind of fit in between the side and the teeth. So how big, or say the size range of the rocks that we could probably use?
Input or output?
Input.
I'm sorry. Sorry, it's coming a little low.
I was wondering if you were curious about the input size of the rocks or the output size of the rocks.
Were you curious about the input size of the rocks or the output size of the rocks?
Mainly the input. Yeah. So what are the size? Yeah, that you can actually feed into this.
Does anybody have any?
Right now, we're hoping that we're hoping that we can get somewhere upper close to 5 to 6 inches, but we're going to have to experiment a little bit to see what the crusher will actually handle once we have a working prototype that's crushing rocks to see how big of a rock we can get to crush. But we think we can get something as large as 5 inches right now crushed.
Okay, I'm sorry. It was little low. It was
5 inches.
4 to 5 inches, or what?
4 to 5 inches is what we're hoping for, but we are going to have to test it and figure out once we have a working prototype that's crushing rocks.
Okay. Thank you.
Any other question? No? Okay.